everyone, welcome to the hopefully corrected 6.5 notes. These are going to be about exponential equations. So the first thing we need to talk about is what in the world is an exponential equation? It is just simply an equation where the exponent is a variable. So if you look down at all of the examples in this table for the notes, you'll notice that there is an x in every single problem that is an exponent. In fact, there are no x's on here that aren't in an exponent. So that's kind of what we're going to try and work around today. And there's two ways of doing this. Today, what we're going to talk about is kind of how to work around it. There's no way to sort of like cancel an exponent. There is a way you could switch to what's called log form. But before we go as far as using logs, what we're going to do first is use this one simple rule, that if you have something to 1 power and it equals, that should be an a to the power of z. Let me grab my whiteout and I'll fix that. There we go. So these had to be the same letter. That's why I had to change that. So if you have two things that are set equal and they have the same base like this, then that means that they have to have the same exponent too. And I'm actually going to kind of jump to our first example and just kind of go over it before I even do the steps. Because basically what I'm saying is, since these are both 3's, that means that x plus 1 has to equal 5. Because 3 to the 5th is going to equal 3 to the 5th. So then you can set this up like an equation without the 3's that are on bottom, because all we really care about is that that was the same number. And then I'm solving this like a regular equation. So I'm going to subtract 1, and I get x equals 4. Which, if I plug that back in, 4 plus 1 is 5, and 3 to the power of 5 is 3 to the power of 5. Look at that. And that's basically what we're going to do here. And I'm going to keep solving these along the top row, and then I'll explain the steps afterwards, I promise. So on this next one, we know that this has to equal the exponent right here. But there is no exponent, so what do? We give it the automatic exponent of 1. Because if we want this to be 1, if 6 to the first power is going to equal 6. So basically I have the equation 1 equals 2x minus 3. So I'm going to add 3 to both sides. And then you're going to divide by that too. So even though these equations look kind of scary, you're really just solving them like normal ones by picking out the parts that are important. So the 6's aren't important, just the fact that they are the same is what's important. And then over here on the right, we have 2 10's. So this has to equal this. So 3x equals 2x plus 3 minus the 2x minus the 2x. And there you have it. Now, what you'll notice down here in the second row is these aren't the same number anymore. Only one side has an exponent on this one, and only one side has an exponent on this one. So that's where our steps are going to come into play. And the first step is going to be to make every exponent have the same base. This is going to involve some substitution. I didn't have to do that step on any of these 3 because look, they already had the same base. But these don't, so I'm going to have to change it. Then you set the exponents equal. That's what I did here, where I said x plus 1 equals 5. 1 equals 2x minus 3, and 3x equals 2x plus 3. What that basically means is that the bases are going to go away. Now, the hardest part is the first step. So what I'm going to do is I'm going to go through and do just this first step on all of the problems that we have left, and then I will go ahead and set them equal and solve, okay? So here's what's basically happening. This is already 5 to the power of x. And you can't really rewrite 5 as the power of any other number because there's nothing that goes into 5. But I can rewrite 125 as 5 cubed because 125 and 5 cubed are the same thing. But I have to replace it or substitute it with 5 to the third power so that now they both have a base of 5. And then I'm going to do the same thing on the next one. This one already has a base of 2, so I need to figure out 2 to what power is 4. That's basically my goal. And then I'm going to keep the x on the outside and the 2 to the power of x minus 3 over here. So really, you're just changing this to something that has a base of 2. 2 squared is 4, so I'm going to change this to 2 squared. And that's the setup. Now I have the same base. And again, I'm just setting them up for right now. Over here, 9 squared is 81, and 9 is 9. So there's nowhere to get from 9 to 27 by doing a power. You could multiply, but we don't want to multiply, we want a power. So instead, we're going to have to change both sides. Most people are pretty familiar with the fact that 9 is 3 squared. And the reason why I'm changing that to 3 squared is because I can change 27 to 3 cubed. So now they both have a base of 3. So I had to find another number different than these two to be my common base, because there's no power of 9 that gets me 27. Now, notice how I did it again. This was 3 squared, so I put that in parentheses. When you are substituting, it is a good idea to start with putting that thing in parentheses. And then I just left this out here, and then this is 3 to the third. I'm going to keep just setting them up. I promise you I'll solve them in a second. Over here, I'm going to leave the 6 to the power of 3x. These typically freak people out because there's a fraction. Keep in mind, our main rule about exponents that involve fractions is negative exponents create fractions. So really what's happening is this is 6 squared is 36, right? But it's not 36, it's 1 over 36. The only difference is that this is 6 to the negative second power instead of 6 to the second power. That's the only difference, guys. So same idea on the next problem. This 2 is on the bottom. That's 2 to the negative first power. Now, it needs the negative because it's 1 over, and then it's just 2 still. It didn't change the value of the number, so that's why it's the negative first. This one changed from 6 to 36, that's why it was the negative second power. And then over here, 4 is 2 squared. There you go. And then our last one, sorry about that. We're going to keep the left side the same because it already has a base of 4. And on the right side, 4 to the third power is 64. Because it's 1 over 64, you just change that power to negative 3 instead of 3. So anytime you see these fractions, people typically will skip these problems because they look difficult. That just means it had a negative exponent. And once you change that, you don't have a fraction anymore, and it's just as easy as the other ones. Now I'm going to solve them all of the way. So on this one, I'm going to set my exponents equal, and I have x equals 3, which does not require any solving. You just leave it. And over here, if you have a power to another power, those get multiplied. So that's going to become 2x equals x minus 3. And then I would subtract this x. If it helps you, put a 1 in front of them. So I'm really subtracting 1x. Well, 2x minus 1x is 1x equals negative 3. Remember that when you're solving equations, your goal is to get x all by itself. And then coming over here to the right, I have to multiply these, which means I'm going to distribute like this. So this is going to become 2x plus 4 equals 3. Now it is okay if you end up getting a fraction. I'm going to subtract this 4 to the other side. 2x equals negative 1. Let the fractions be your friend instead of your enemy, because I need to divide by 2 on both sides, but I can't divide 1 by 2, so guess what? My answer is negative 1/2. I don't have to actually divide it because they're not divisible. There we go. Dividable isn't a word. Okay, coming down, 3x equals negative 2. Again, let the fractions be your friends instead of your enemies. You're going to go divide by 3. Negative 2 does not divide by 3, so your answer is just simply negative 2/3. And in the middle, we've got to multiply these two, so that's going to be negative x equals 2. The bases do not matter. This could have been 28 for all I care. As long as they're the same number, you just set these two equal. But you can't solve it like this or like this until you have the same number as the base. Okay, I'm dividing that negative 1 to the other side technically. And over here, x plus 1 equals negative 3. Subtract that 1 on both sides. X equals negative 4. Keep in mind, anytime you see a fraction, it's because you need to change the base and give it a negative exponent.